Hello everyone, in this section we are going to cover the types of BGP. So basically it's of the BGP contain the two types of BGP. One is the eBGP, another is the iBGP. As the name says the eBGP, it means that external, right? External BGP means what? Whenever the router is going to form the neighborship with the different AS number. For example, this is my R1, this is my own company that has a AS number 1, a public AS number I'm going to use between this guy, and have another company with this guy. So this guy has a AS number 2. So whatever the neighborship that I'm going to form between this guy AS number 1 and AS number 2, this neighborship is known as a eBGP, also known as a external connection, right? Whereas if I'm going to talk about the internal BGP, internal is what? Within the same AS number I'm going to form the neighborship. For example, we have a R1, we have a R2, and we have a R3, and this guy has a same AS number 1. So the neighborship between this person R1 and R2 is known as the iBGP neighborship, and R2 and R3 it's known as the iBGP neighborship. It's known as the internal neighborship. Whereas if R1 is going to form the neighborship with a different person, for example this is the R4 router that has a AS number 2, and if R1 is going to form the neighborship with this person, this is known as a eBGP. So always the iBGP is recommended to use in the transit AS like a ISP. ISP is also always behave like a transit AS. So we always use the iBGP connection in the transit AS. Let's see the much detail about the iBGP and eBGP. So eBGP is used to implement at the edge router. Edge router in the sense of what? For example, this is my own company, and in this company we have this is my ISP connection. Okay, and we have a R1 over there. We have the switch connected over there. We have a multiple users of the PCs. Another PC we have then we have a R2, and then we have a R2 also have some LAN network over there, and we have a R3. So this R3 is my edge router for this company, and that's R3 is going to form the neighborship with the ISP. This is known as a eBGP connection. That's provide the interconnectivity between the two or more autonomous system number. eBGP peering are a core component of the BGP protocol on the internet side. Without eBGP, you cannot reach to the one location to the different location. For example, if you are, you are present in the Bangalore location and you need to access the Google.com or the Facebook.com, without eBGP, it's not possible. You have to run the eBGP. Now, by default, the TTL value set to the BGP packet is set to the 1. What's the meaning of that? Whenever the BGP will send any packets, right? We have for example, we have a source IP address. Just take example of this scenario, 12.1. Destination is 12.2. Right? Whenever I'm going to send any request to the R1 to R2, the TTL value should be 1 over there. So R1 will process this packet to the R2. But the same packet R2 will not process to the R3. That's the meaning of set to the TTL 1. Then by default, in eBGP next hop is modified. So just take example, we have some LAN network over there. So I'm going to cover right now this portion. So for example, we have a LAN network that's a 1.0.0.0. I'm going to send this, R1 will send this information to the R2. So how the packet will look like this? R1 will put the subnet 1.0.0.0/8. Right? This /8 is going to represent that this is my classless routing protocol, because only classless routing protocol contains the subnet mask information in the update packet. So in this one, what happened? The next stop will be 12.1. So when R2 will receive this packet, it will maintain this information as a B for BGP 1.0.0.0, and next stop will be 12.1. When the R2 will receive it, by default the next stop is modified. R2 will process the same update packet to the R3, but in this section what happened? Now R2 will send this update. R2 will change this next stop from 12.1 to the 23.2. In a R3 routing table, we will have a same update B 1.0.0.0.0, and that has a next stop will be now 23.2. That's the meaning of next stop is modified. At the same time, the advertising router prepend its AS number. So when the BGP router, the first thing is that modify the AS number, right? Second thing is that when the BGP router is going to send the own update to the R2, it will put the own AS number over there that has the AS number, for example 1. When R2 will send this update to the R3, now the update will look like this. For example, we have a same concept. So we have a source with 23.2 now, 23.3 destination, and now the AS number I'm going to prepare it as it at 2. Come on. So when R3 will receive this update, what R3 will do, they will maintain this information BGP 1.0.0.0. That's my next of 23.2, and I'm going to mention this guy as a AS number will be 2 and 1. Whereas in the R2 routing table, we will have an information like a AS number 1. We'll see that in much detail. Don't worry, I'm just giving the overview right now. And after that, whatever the route that I'm going to advertise through the BGP protocol, that has a AD by default 20. So this guy has a AD 20 and this guy has a AD 20 by default. So this is overview of the eBGP. Same we have a iBGP. In the iBGP, what happened? Now you can see that this diagram R1, R2, R3, all these guys present same AS number 1 to 3. So when you have all router present the same autonomous system number, that neighborship is known as a iBGP, or also we can say that internal neighborship. iBGP is always recommended to use in the transit AS. You should always run the iBGP on an all router within the same AS number. Right now R1, R2, R3 is present same AS number. By default, iBGP does not change the next hop. So when the R1, for example, this is the update 1.0.0.0, R1 will send this update to the R2. See, they have a iBGP neighborship over there. So they will have a source IP address 12.1, they have destination IP address 12.2, right? And this update is the 1.0.0.0.0. When R1 will send this update to the R2, R2 will receive this update on this interface. What R2 will do, they will maintain this information 1.0.0.0.0 as a next hop 12.1. But at the same time, R2 cannot modify. When R2 will send this update to the R3, it won't modify the next hop information. It is still in a R3 BGP table. We have a 1.0.0.0.0. The next hop will be 12.1. The next hop will be not modified. At the same time, in an iBGP router, what happened? The AS path information will be not there. The AS path empty. If you remember that, in an eBGP case, what happened? The AS path was there, but in the iBGP it does not. And the AD of iBGP route is the 200. For this person 200 and for this person 200. So this is my iBGP. Thank you so much for watching this video.